Dear all, welcome to today's lecture on design and engineering. In our previous lecture, we had covered the topic on how to identify the customer needs or requirements. So there were different methods by which we could collect the customer requirements and we could correctly analyze the customer requirements so that a proper design for the required product can be made. Now in today's lecture, we will be covering other different important aspects in design, like design objectives, how to set the design objectives and how to finalize the design objectives, how to identify the design constraints, and then what are design functions and how do we try to establish these design functions. So design objectives are actually the conversion of the requirements of the customer. So whenever we collect the requirement from a customer, as we discussed in the previous class, the customer requirement is not always very clear. The customer only has a very vague idea or not so clear idea about the final product or the service that he wants. So it is the duty of the design team and the teams that are collaborating with the design team to correctly analyze and identify these customer requirements and convert these customer requirements into a meaningful term or a meaningful idea. Meaningful in the sense it should be converted into engineering terms. Suppose that a customer says, I need a very light mobile phone. So light can mean a lot of things. So it is very difficult for the design team to understand what the word light means. The customer might have meant that it should be very easy to carry, or maybe it is very portable, the size should be small, or maybe even the weight is less. Only the customer knows what actually he has demanded. But the design team, if they are not inferring these requirements of the customer correctly, then they may end up in producing an entirely different product which the customer might not really like. So it will result in customer dissatisfaction and it will again certainly result in the wastage of resources, time, money, etc. So setting of design objectives is therefore very essential. So whenever the customer tells a requirement, these requirements are converted into objectives. So objectives actually convert the customer requirements into a more clear form, so that the customer can also look into it and check whether it is the same thing that the customer has asked for, and also the design team gets a chance to clarify whether this is the same requirement that the customer has meant. So it is equally important for the customer and the design team to set a design objective to clarify the customer requirements. So before initiating the design objectives should be framed based on the customer requirements, and it will provide a structure and clarity for the customer as well as for the organization that is producing the product. And objectives usually are expressed in verbal terms, in simple terms. Like example given here, the customer wanted a portable drilling machine, a lightweighted drilling machine. So portable drilling machine is an objective, a design objective. But then again, more clarification has to be made in this particular objective. As mentioned earlier, portable can mean a lot of things. Portable can be small in size, but can be light weighted or easy to a handle, it can mean a lot of things. So it is very essential to clarify the requirements and also the design objectives to the maximum detail possible. Now some of the design objectives mentioned are: first is to identify the needs of the user. One of the objectives of during the design process is to identify the needs of the user, because the product will be based on the user requirement. We cannot make a product which the user has not demanded. A product will exist in the market only when there is a customer requirement. So it is essential to identify the needs of the user, then to do research and to know the various possibilities of problem solving. So while framing objectives, we should research further on the needs of the user and whether any solutions to the existing problem means the requirement, whether it actually exists in the market. If it is existing, then the customer may need only a slight modification of the existing solution. If the solution is not existing in the market, then a new product will have to be made as per the specifications or the requirements from the customer. So for that, the design team must do a lot of research to identify how the requirement of the customer can be solved. Then to reduce the cost of the design process, what all things can be done by the design team? They can simplify the design, they can reduce the processes that are assigned, that are associated with making the design as well as during the product development, so that the overall cost can be reduced. But keeping in mind that all this cost reduction will not affect the customer requirements being satisfied. All the requirements should be satisfied. Whether all these requirements can be satisfied at a reduced cost, that is the matter that the design team should focus. Reduce the complexity of the component. So whenever we are simplifying the design process, the component geometry and the shape etc. becomes very more simpler, more easier to produce. So always one objective for the design team should be to reduce the complexity of the component, the number of parts that make up the component if it is an assembly. So try to minimize the complexity for designing and making that component. Then to increase the efficiency of the component, to complete product design within the specified time. That is a very important factor, because once the design team starts with the product design, the customer will have a delivery date for the product. So this product has to be designed, it has to pass all the design specifications, then it has to be manufactured, it has to be tested in customer environments, and finally the product has to be shipped to the customer, and all of this has to happen within the specified time frame. If the customer is not getting the product within the specified time, again there is a customer dissatisfaction and it will lead to customer going to another product, changing the product. So that will again result in a loss of customers and a loss of revenue or profits for the company. So that should be avoided. Then to make the design more ergonomic and user friendly, so the design, even if the customer has specified his requirements, the design team should focus on making the design more user friendly. So ergonomic means more user friendly, more comfortable to the user. Stating the earlier example of a portable drilling machine, we can make or we can design the drilling machine in several methods. Several designs can be made, but ultimately when the customer is using that product, he should be feeling very comfortable. If it is not comfortable, even if the product is lightweight and it is not comfortable, the customer will not like it and there will be customer dissatisfaction. Then the next objective is to improve the safety of the component under very static and dynamic loads. So safety is another important consideration that is to be given, because if the product fails when the customer is using it, the customer will become annoyed, angry or dissatisfied, because the product did not serve its purpose. So it failed, it broke down, or it is not functioning, it needs maintenance. So the customer was not expecting that. Customer was expecting a quality product, and the product which the organization or the company supplied did not meet the standards. So again, customer dissatisfaction is the result. Then next objective is to make an eco-friendly material. So eco-friendly material in the sense, the material used to make the product should not be harmful to the environment. It should not cause any toxic gases or any toxic waste or undegradable, non-degradable waste, etc. It should be made of an eco-friendly material. So that probably is not given much due consideration, but it is a very important factor that has to be considered. And the final objective is to create a self-sustainable component. So these are some of the design objectives that should be kept in mind while designing a product by the design team. Now, how do we set the design objectives? There are several methods by which we can set the design objectives. And objectives, as we mentioned, even if it is mentioned in a very few words, it has a lot of meaning. Customer says a portable drilling machine or a portable any other device, it can mean a lot of things. Either it should be lightweight, should be easy to carry, should be very small, and should be ergonomic. So a lot of things can be meant in a few words. So formulating or setting objectives is not very easy, because we should correctly identify what actually the customer meant and how we can correctly frame an objective relating to that requirement. And setting objectives will need some imagination, creativity and realism. So a designer or the design team should actually be a very creative team. They should think, they should discuss and bring in more ideas, so that the customer requirements that the customer has specified can be converted into a meaningful product that the customer will like. So a lot of things have to be imagined, a lot of creativity has to be brought in, and the experience of the design team has to be brought in during the design process. Now, what is the smart way? That is one of the methods by which we can set the objectives. SMART actually is an acronym or a short form. The words, the letters S, M, A, R and T have their own different meanings in this word SMART. So let us see what SMART means. When we set an objective, it may not be related to design. Generally, when we are setting an objective for doing anything, say for example your project, academic project also, the same thing can be applied, setting a SMART objective. Now what is a SMART objective? Yes, in this word SMART refers to specific. Specific means very precise, pinpointed, accurate. Whether the objective specified is to the point, is it precise, or is it a vague or an ambiguous? Ambiguous in the sense it is a confusing statement. It should not be confusing, it should be to the point, precise. Does the objective state a defined outcome or a result? For example, if you are saying portable drilling machine, it has a lot of embedded meaning in it. So it is not clearly telling you what actually the product should be. So does the objective has a defined outcome? So when we are proceeding with the objective, whether we are able to achieve the final outcome or result as specified. Being specific about about an outcome leads to the identification of what will be achieved. So whenever we are setting a clear objective, a specific objective, we will be clear throughout the entire process and finally in the product what has to be achieved in the product. So specific means clarity, it should be very clear. Then second word M in the word smart refers to measurable. Measurable in the sense, can we measure the outcome or can we quantify the outcome? And if it can be quantified, how can we quantify or express the outcome in measurable terms? And if the outcome cannot be quantified, then are there any other indicators or things which will show that the objective has been met or satisfied? So whenever the objective is specified, you will check whether the objective is in a measure, can be measurable. For example, if the customer is saying, I want a lightweight drilling machine, so then there is a measurable parameter being brought in, the lightweight in the sense how much light it should be, what is the maximum weight that the product should have. All those things if we are specifying, then that is measurable. Example, we are designing a portable drilling machine under 2 kg, maximum weight should be 2 kg. So there is a measurable aspect. So always we should frame the objectives such that it is measurable. And if it cannot be measured, then there should be other indicators that will tell you whether the objective has been satisfied or not. And who will be measuring the achievement, when it will be measured and how often? So who is going to check whether the objective is met? What time point will that be measured whether the objective is met? And how often or how frequently you are going to measure whether the objective is met? Suppose we have a number of objectives, then it is very important to check every now and then that during the design process whether all the objectives as specified by the customer requirement has been converted into objective, whether all these objectives are being met or not. So we should identify who is going to measure this objective, whether it is completed or not, then when or at what point of time the measurement will take place, and how frequently all these objectives are checked with, whether it is satisfied or not. So that is meant by the term measurable. So measurable objectives, they help in an evaluation or an assessment, and they give an idea of how much the current objective or the current process will give you, or whether the current process will give you the intended outcome. If you are doing the current process or the current design process, whether this is going to end up in a product which the customer has specified, or whether the product will not meet certain requirements. All those will be the end result that the measurable objective can give. Then the letter A refers to achievable. Achievable means whether the objective can be achieved or not. So there is no point in setting very high objectives, highly standard objectives which the company cannot meet. Suppose the customer is giving you a requirement, the product should be of high quality, and you are going to make a product with a good quality material, but the cost is very high, but the cost as specified by the customer and the cost that is incurred by the company while production is very high. So the customer cost, the cost that the customer is able to pay or he is ready to pay, the cost of actual production is actually very much higher than that, so that it is the final product appears to be very costly. So if you are setting such an objective, then it is not in line with the customer expectation. Customer is expecting a high quality product but at a comparatively cheaper price, but he is getting a high quality product from your company but at a very higher price. So that is not a customer expectation. Whether the objective is within the organizational capabilities, whether the company has the ample or enough technology or resources to make that product or to achieve the objectives that is specified. So that mentions organizational capability, whether the organization is capable of doing or taking that objective. Then is it set within the available resources, that is time or money. Time is an important factor. As mentioned earlier, the product should reach the customer within a specified time. Now, certain conditions have to be considered along with their impact on deciding whether the objective is achievable or not. So these three types of questions can give you a correct idea of whether the objective is achievable or not. Answers to this question will give you an idea. Questions are: what is in our control? What all things are there in our control or things which we are able to control? What do we have influence over, and what do we have to accept and cannot change? So these are the three types of questions that can be or that the organization has to ask itself to check whether the objectives are achievable or not. What is in our control means things that can be controlled by the organization, things that we can influence and control in the organization, and things which are not under our control that we have to accept. So if we are able to identify all these things, then it is easier to frame an achievable objective. Then R refers to relevant. Relevant means it is important to the customer or it is appropriate to the customer. And does it link to the objectives and priorities of the team, department and organization? So whenever we are setting an objective, it is very important to see whether that objective that is being set does not contradict the working of the organization, whether the priorities of the team or the organization are being crossed over, whether while we are setting the objective, that should be checked. So relevant here refers to the importance, whether the objectives being set are important to the customer. Time frame. Time frame means the objectives are constrained within a time frame. Whether a date has been set for completion of each objective. Suppose there are 5 or 6 objectives, there should be a definite time frame set for completion of each of these objectives. If we are not setting any time frame for any activity, it will go on continuing forever. There will be a lot of modifications, again iterations will go on, and it will continue forever. So in order to avoid that, each activity, especially setting the objective, has to be given a certain time limit within which this has to be completed. identifying whether the objectives are long term, medium term or short term, whether the objectives to be satisfied in the product are based on long term, or whether it is designed for a medium term, or whether it is for an immediate or a short term. And for long term objectives, long term refers to a number of years. If long term objectives are going to be set for the project or for the product, then it should be ensured that there are a number of intermediate steps or intermediate phases. Each intermediate phase should have a definite completion time. A specific time should be specified for its completion, and a review of each of these intermediate phases should be done intermittently. Only then we can ensure successful long-term objectives to be met. So long-term objectives, they are satisfied over a long period of time. So such a long period of time, it is very difficult to plan. So what we do is we plan at different intermediate phases. Whether these intermediate phases are satisfied correctly, it will finally lead to the satisfaction or the meeting of the final objective, the long-term objective. So after we have set the design objectives, now we need to finalize the design objective. So finalizing the design objectives, there are certain different methods. The two main methods commonly used are absolute comparison and relative comparison. In absolute comparison, we compare our existing design concept with a standard concept. The design concept which we are developing, we compare that to a standard concept that is already available as a standard. And a relative comparison means we are comparing different design concepts which we ourselves have developed, or maybe design concepts with our competitors. So here there is no standard, we are only comparing the newly developed design concepts with one another. That is known as a relative comparison. Now there are certain evaluation methods to finalize the design objectives, to check whether the objectives are met or not, that is evaluation. First is evaluation based on feasibility of design. Checking the feasibility or workability of design, whether the idea or whether the design concept will be, or the design objective will work or not. So the division is feasible, means the idea will work or the design will work, and it is taken for further development. Conditional means the idea may work or may not work, we don't know. If the idea might work, then we might have to do some modifications on that existing idea, and that is known as conditional. And infeasible means the idea, when we are looking at itself, we can clearly identify that the idea will not work anyway. So that is infeasible idea or infeasible design. So infeasible design, there is no point in taking it further. We have to discard that idea or the design concept. Then the second evaluation is based on the availability of technology. Availability of technology means whether the technology is actually available to us currently. So there is no point in making all the designs and our company to wait for the technology to come to us. Suppose the technology to build that product exists only in foreign countries, and suppose our company is in India. So we cannot wait forever for that technology to come to India, and then we need to switch over to that technology and then start with the design and manufacturing process. No, that cannot happen. So we have to check whether the technology is currently available with us so that we can start working on it right away. Can the technology be developed with known sources? So suppose the technology is not available with us, the next thing that we should check is whether we can develop that technology with the resources that are available with us. If it can be developed easily, it is fine and good, we can proceed further. If the technology cannot be developed by us, if it is very costly or if the resources are not available with us, then we should drop it then and there. Then are the functional parameters identified? Are the functional parameters for the design or for the product correctly identified? These are the things which we check during the evaluation based on availability of technology. Then the evaluation based on customer requirements, whether the customer requirements are satisfied or not. So this type of evaluation is used or is applied only when the first and second evaluation methods are satisfied by the product. If it clears first and second evaluation method, then the product can be subjected to the third evaluation. Here the customer requirements or the objectives are framed into different questions and they are matched with the design concepts. So certain questions will be there, whether the product is lightweight, whether the product is of high quality, whether the product is small in size, etc. Such questions are framed, are made, and whether the answers of these questions are matched with the concepts. So we can exactly know for each of the answers to these questions whether it is satisfying the customer requirement or not. So the design concepts which are not meeting the customer requirements, they are obviously the product cannot go further without satisfying those requirements. So those designs are discarded, and for those in which some improvements or adjustments can be made, they are subjected to a few more iterative cycles, and we try to check whether the customer requirements are now met or not. And even if after a few iterations the requirements are not met, then again we have to discard that design concept. So always we check thoroughly whether the customer requirements are being met at each stage of the design process. Not just one stage, in all the stages in design and during the development process or the manufacturing process and testing process, until the product reaches the customer, we have to check intermittently and frequently whether the customer requirements are satisfied or not. Now coming to design constraints. Design constraints means the constraints or the limitations within which the design has to exist. The limitations actually will control the design. Means we cannot freely design using all the resources available at hand. There has to be certain limits. So these limits which will limit the design process are known as constraints. So every design team or every design engineer has to understand these constraints and prepare a design that will actually be or that will actually satisfy all these constraints. The problem is that when there are a lot of limitations on the design, it will affect the creativity. So we cannot freely create or freely design a product according to our wish. It should satisfy certain it should be within certain limitations. So creating a perfect design therefore is a very difficult and a very time consuming process because we have a lot of constraints. And design constraints refer to the limits that are posed on a design process. So we start with a design, a preliminary design. Preliminary design is essentially or basically a sketch that is produced. If it is a product, initial sketch or a rough sketch will be produced, and this rough sketch or the preliminary design will not take into account any of the design constraints. So after preparing an initial sketch or initial idea, when we try to bring it to the next stage, then all these design constraints have to be applied on it. So when these design constraints are being applied to the preliminary idea or the preliminary design, a lot of changes will have to be made accordingly so that the constraints are satisfied. So the initial sketch or the initial design made for the particular product by the design engineer will be very much different from the final end product design because a lot of design changes will be happening intermittently, so that all these constraints and requirements, everything has to be incorporated or added into the product. And the necessary constraints to be considered include a lot of constraints which we will be seeing later on in these slides, like technical, social, economical, environmental. A lot of other constraints are there, ecological, a lot of constraints are there which will limit the design process. Some examples are being shown here, like should a design work at high temperature, should the product be portable, should it meet the environmental regulation. So a lot of constraints are being applied to the product so that the design has to be shaped accordingly. Now what is the relation between design objective and constraints? Design objectives actually gives us a wide variety of choice, whereas constraints is just the opposite. It will limit the design, limit the choices in the design. A portable drilling machine is an example of an objective. Portable can mean a lot of things as we discussed earlier. So it is a wider design space. The design engineer can design the machine as a lightweight machine, as a ergonomic machine, user friendly machine, as a reduced size machine. Lot of things, lot of design aspects can be brought. Whereas if we are specifying the constraints, for example, the drill weight should not exceed 1.5 kilogram, then there is a constraint that the total weight should not exceed 1.5 kilogram. So we need to make the design or change the design accordingly. We need to select the materials for the design accordingly so that it is a lightweight design, and shape etc. has to be changed accordingly to reduce the weight. So a lot of things has to be considered. So objectives will give you a wide choice for design, whereas the constraints will limit the design choice. And here it shows the different constraints. The different points, fixed points, represent the constraints or the limits within which the design has to be made. So let us see what are the different limitations or different constraints that will limit the design process. First is functional constraint. Functional constraints are actually constraints which affect the functionality of the product. Functionality in the sense working principle. It can be either overall geometry. Overall geometry means the size, shape, volume, dimensions, space requirements, etc. that has to be satisfied by the system. Functional constraints again can be related to kinematics. Kinematics means the forces that are being applied on the product or the system. What are the different types of forces, the different stresses that are developed, the different loading conditions that the product is subjected to. The product should not fail under the application of such applied forces or load. So that is the functional constraint that is related with the kinematics or the forces. Then functional constraints related with the energy requirement. What is the input energy or the energy source required by the product to operate, and what quantity of energy is required, whether we need to amplify the energy to a higher level or not. All these are the energy requirements. Then what are the materials used? Materials used again depend on the strength and quality of the final product. It can be either a high quality material or a medium quality or a low quality material, and accordingly such type of materials should be used for building that product. And again the materials used depend on the availability of the material, whether it is easily available, whether it is available in cheap, or whether it is very rare, difficult to hold the material, etc. Whether it can be easily machined, that is machinability, whether other manufacturing processes can be done on that material easily. All these factors are checked for the materials used consideration. Control system. What controls the product, or the type of signals which control the product? Uses of sensors and other actuators or other such devices which controls the product. How the energy transfers or the signal transfers takes place from one region of the product to another. What are the different components that are made in that or that are used in that product? So all these are listed under the control system. Then how the information flow is taking place and what kind of information is being supplied to the end user, like whether it is a graphical data and whether it is a numerical data, and whether the instruments are or the products are calibrated and whether the errors are measured, etc. All these are listed under information flow. So the functional constraints consists of overall geometry, kinematics involved, energy requirement, materials used, control system, and information flow. The next type of constraints are the constraints that are related with the safety of the product. Safety constraints means if we are not giving attention to such constraints, whether it will cause any harmful effect to the end user or to the product. So every product that the end user uses should be designed with a factor of safety. Factor of safety means only if the product is used beyond that factor, then the damage should take place. So under normal conditions or normal operating conditions, when the product is being used by the user under normal condition, it should not fail or it should not cause any harmful effect to the product or to the user. And it consists of the operational safety constraints, that is the constraints that are applied during the normal operational condition. Then the environmental constraints, like For example, humidity or any corrosive environment or heat, etc. And human errors during operation. Human errors in the sense the customers who are operating that product, they can sometimes operate the product in a wrong way or can commit any mistakes during its operation. So that should not cause any harmful effect to the product or to the user. So while designing the product, all these safety aspects are kept in mind. So they are known as safety constraints. Then we have the quality constraints, which means the product that is designed should be of high quality. So high quality, again, it brings a lot of constraints, which means only selected materials can be used for high quality. So what are those materials that can be used, and whether using those materials will give you or give the product high quality or not. And the quality checking has to be conducted by testing the product several times, and after that we ensure the product is of high quality. Then we have the manufacturing constraints, which means the constraints which are encountered or which are experienced during the actual manufacture. So after the design phase, when the product enters into the manufacturing phase, what are the limitations that has to be kept in mind? Labor shortage can be there, machining time, then the different methods of manufacturing, the amount of wastage that is occurring during the manufacturing process, the inefficiency of the machines. All these can be the different manufacturing constraints. So that has to be considered, because only after satisfying only after considering all these constraints, we can actually manufacture the product. So all these are the different conditions which the product will encounter during actual manufacturing process. So we have to take into account the actual manufacturing constraints also. Then time constraints. If we are giving a very short period of time for the entire process, the design and development of the product should happen within a very short span of time. But during the entire cycle, in every organization, it is noticed that the design and development phase, actually the research and design phase takes the maximum time or the maximum cycle time or the stage time. So the maximum time is allocated for design and the development stages. More time is given to the research and design phase, because a lot of innovative ideas has to be generated and the feasibility of these designs has to be checked. So if we are giving only a slight or a small amount of time, there are chances that a good design may not appear. The designer will not get enough time to prepare a good design. So it will result in a mediocre design. And the design and development stages should be given sufficient time to get the best product. So if a good design has to come up, then sufficient time has to be allocated. And then we have economic constraints. That means the design should be within the specified economics, that is the cost. If it is going out of cost, or if the cost is incurred is very high, then it is very difficult for the design to proceed further. And there are certain factors which influence the economic constraints, like the demand for the product, design cost, design development and manufacturing and distribution costs, and availability of resources. So these are the factors that influence economic constraints. Then we have ecological constraints, which deals with the environment, that the product should have or should not have a negative impact on our environment. It should not have any toxic residues, and it should be very friendly with the environment, and it should not produce any undegradable or non-degradable waste, etc. Then legal and ethical constraints deal with the patents and copyrights. All the products or the designs created um, should have the sanctions from the legal and ethical constraints. So it should satisfy legal and ethical constraints. And there should not be any plagiarism. Plagiarism in the sense, plagiarism means it is a copy. A product or a design of a product should not be copied entirely from another product. There should be, or if there are, suppose there are two products from two competitors, one competitor should not copy the design from another competitor, and it will lead to plagiarism, and again legal actions will have to be taken for that copy. Then there is ergonomical and aesthetic constraints, which deals with the comfortability and the user friendliness. The products should have an ergonomic design, and whenever we are designing a product, the user and the product interaction should be kept in mind. How the product is going to be used by the user, whether the product is going to be user friendly, whether the customer is very satisfied or very comfortable in using the product or not. The functional constraints are affected by the aesthetic nature of the product. So when we are trying to incorporate or add more aesthetics or comfortability to the product, then some functional aspects are affected. So that means giving more attention to one type of constraint will, or it will affect the fulfillment of other constraints. So we have to check all these constraints equally, giving equal importance, and should be based on the requirement of the customer. If the customer has certain functional constraints or is specifying certain functionalities, these functional constraints should be, these functionalities should be met in the product. That much functional constraints are imposed on the product. Visually pleasing product, in the sense, if we are making the product to be visually very good, the customer will be more attracted to the product. We are naturally attracted to products which are very good looking and which are very good to see, and new designs, etc. So such kind of products will attract more customers. But it should be kept in mind that entirely giving your attention to the ergonomic and aesthetical constraints can lead to the misfunctional or absence of other functionalities being satisfied in the product.